Good day, everyone. Today we'll discuss the introduction to our module on roots of equations. First, we will discuss the different types of equations. First, we have algebraic equations. By definition, a function given by y is equal to f of x is algebraic if it can be expressed in the form as shown in this equation, where f sub I is an ith order polynomial in x. Polynomials are a simple class of algebraic functions that are represented generally by this equation, where n is the order of the polynomial and the a's are the constants. The roots of polynomial functions depend on n. The roots will either be real or complex conjugates. The next type of equation is transcendental functions. A transcendental function is one that is non-algebraic. These include trigonometric, exponential, logarithmic, and other less familiar functions. Examples include f of x is equal to ln of x squared minus 1, and f of x is equal to e raised to negative 0.2x times sine 3x minus 0.5. For a transcendental function, there can be infinite number of roots, finite number of roots, or no root at all. Iterative method. It involves iteration in such a way that the computed values of x are convergent. The values of x are convergent if they are approaching the actual root value, otherwise it is divergent. If the given equation has the form wherein f of x is a nonlinear function, then an iterative equation of the form can be acquired as well as an iteration formula of the form. This technique is very efficient in solving for the roots of both nonlinear polynomial and transcendental functions. The iterative method contains two major components. We have the iterative formula and a terminating condition. The terminating condition states when to stop applying the iterative formula. It may be stated as, first, if by chance the computed value after applying the iterative formula turns out to be the actual root, then the process is terminated. Second, if a specified number of iterations is given in the problem. And third, if the given error criterion of the problem is satisfied. For the roots of equations, we have two techniques or methods. First, we have the bracketing techniques. These techniques are so-called bracketing techniques because two initial guesses for the root are required. And these guesses must bracket or be on the either side of the root. The particular methods described herein employ different strategies to systematically reduce the width of the bracket and home in on the correct answer. Two methods are covered. We have the bisection method and the false position method. Next is the open methods. In contrast, the open methods are based on formulas that require only a single starting value of x, or two starting values that do not necessarily bracket the root. They sometimes diverge or move away from the true root as the computation progresses. However, when the open methods converge, they usually do so much more quickly than the bracketing methods. We will cover three methods. We have the second method, Newton-Raphson method, and the fixed point iteration method. That ends our discussion for the introduction of our module on roots of equations. Thank you.